The NewTek Video Toaster was a combination of hardware and software for the editing and production of NTSC standard definition video. The plug-in expansion card initially worked with the Amiga 2000 computer and provided a number of BNC connectors on the exposed rear edge that provided connectivity to common analog video sources like videotape. The related software tools supported video switching, chroma keying, character generation, animation, and image manipulation. Together, the hardware and software provided a low-cost video editing suite for a few $1,000s that rivaled the output of professional systems costing 10 times as much. It allowed small studios to produce high-quality material and resulted in a cottage industry for video production not unlike the success of the Macintosh in the DTP market only a few years earlier. The Video Toaster won the Emmy Award for Technical Achievement in 1993. Other parts of the original software package were spun off as standalone products, notably Lightwave 3D, and achieved success on their own. As the Amiga platform lost market share and Commodore International went bankrupt in 1994 as a result of declining sales, the Video Toaster was moved to the Microsoft Windows platform where it is still available. The company also produces what is essentially a portable prepackaged version of the Video Toaster along with all the computer hardware needed, as the TiCaster. These became all-digital units in 2014, ending production of the analog Video Toaster line. First-generation systems, the Video Toaster was designed by NewTek founder Tim Jennison in Topeka, Kansas. Engineer Brad Carvey built the first wire-wrap prototype, and Steve Kell wrote the software for the prototype. Many other people worked on the toaster as it developed. The toaster was announced at the World of Commodore Expo in 1987 and released as a commercial product in December 1990 for the Commodore Amiga 2000 computer system, taking advantage of the video-friendly aspects of that system's hardware to deliver the product at an unusually low cost of $2,399. The Amiga was unique among personal computers in that its system clock at 7.16 MHz was precisely double that of the NTSC color carrier frequency, 3.579 MHz, allowing for simple synchronization of the video signal. The hardware component was a full-sized card that went into the Amiga 2000's unique single video expansion slot rather than the standard bus slots, and therefore could not be used with the A500 and A1000 models. The card had several BNC connectors in the rear, which accepted 4 video input sources and provided 2 outputs. This initial generation system was essentially a real-time 4-channel video switcher. One feature of the Video Toaster was the inclusion of Lightwave 3D, a 3D modeling, rendering, and animation program. This program became so popular and useful in its own right that in 1994 it was made available as standalone product separate from the toaster systems. Aside from simple fades and cuts, the Video Toaster had a large variety of character generation, overlays and complex animated switching effects. These effects were in large part performed with the help of the native Amiga graphics chipset, which would be synchronized to the NTSC video signals. As a result, while the toaster was rendering a switching animation, the computer desktop display would not be visible. While these effects were unique and inventive, they could not be modified. Soon toaster effects were seen everywhere, advertising the brand of switcher a particular production company was using. The toaster hardware required very stable input signals, and therefore was often used along with a separate video sync time-base corrector to stabilize the video sources. Third-party low-cost time-base correctors specifically designed to work with the toaster quickly came to market, most of which were designed as standard ISA bus cards, taking advantage of the typically unused bridgeboard slots. The cards did not use the bridgeboard to communicate, simply as a convenient power supply and mechanical location. As with all video switchers that use a frame buffer to create DVEs, the video path through the toaster hardware introduced delays in the signals when the signal was in digital mode. Depending on the video setup of the user, this delay could be quite noticeable when viewed along with the corresponding audio, so some users installed audio delay circuits to match the toaster's video delay lag, as is common practice in video switching studios. A user still needed 3 VTRs and a controller to perform A/B-roll linear video editing, as the toaster would serve merely as a switcher to switch on cue in such a configuration, but the toaster itself had no edit controlling capabilities. The frame delays passing through the toaster and other low-cost video switchers would make precise editing a frustrating endeavor. Internal cards and software from other manufacturers were available to control VTRs. The most common systems went through the serial port to provide single-frame control of a VTR as a capture device for Lightwave animations. A non-linear editing system product would be added later, with the invention of the Video Toaster Flyer, though the product never really worked to professional standards because it could not consistently play video without jitters. As a result, the Flyer never caught on as a viable product. Although initially offered as just an add-on to an Amiga, the product was soon available as a complete turnkey system that included the toaster, Amiga and sync generator. These toaster systems became very popular, primarily because at a cost of around $5,000, they could do much of what a $100,000 professional video switcher could do at that time. The toaster was also the first such video device designed around a general-purpose personal computer that was capable of delivering NTSC broadcast quality signals. As such, during the early 1990s the toaster was widely used by Amiga owners, desktop video enthusiasts and local television studios, and was even used during The Tonight Show regularly to produce special effects for comedy skits. It was often easy to detect a studio that used the toaster by the unique and recognizable special switching effects. The NBC television network also used the video toaster with Lightwave for its promotional campaigns, beginning with the 1990 to 1991 broadcast season. All of the external submarine shots in the TV series Sequest DSV were created using Lightwave 3D, as were the outer space scenes in the TV series Babylon 5. Interestingly, because of the heavy use of dark blues and greens, the external submarine shots in Sequest DSV could not have made it to air without the use of the ASDG EBCAS driver, written specifically to solve this problem by Aaron Avery at ASDG. An updated version called Video Toaster 4000 was later released, using the Amiga 4000's video slot. The 4000 was co-developed by actor Will Wheaton, who worked on product testing and quality control. He later used his public profile to serve as a technology evangelist for the product. The Amiga Video Toaster 4000 source code was released in 2004 by NewTek and Discrete FX. Video Toaster Flyer. For the second generation NewTek introduced the Video Toaster Flyer. The Flyer was a much more capable non-linear editing system. In addition to just processing live video signals, the Flyer made use of hard drives to store video clips as well as audio and allow complex scripted playback. The Flyer was capable of simultaneous dual-channel playback, which allowed the toaster's video switcher to perform transitions and other effects on video clips without the need for rendering. The hardware component was again a card designed for the Amiga Zorro 2 expansion slot, and was primarily designed by Charles Chinchilla. The Flyer portion of the Video Toaster Flyer combination was a complete computer of its own, having its own microprocessor and embedded software, which was written by Marty Flickinger. Its hardware included 3 embedded SCSI controllers. 2 of these SCSI buses were used to store video data, and the third to store audio. The hard drives were thus connected to the Flyer directly and used a proprietary file system layout, rather than being connected to the Amiga's buses, and were available as regular devices using the included DOS driver. The Flyer used a proprietary wavelet compression algorithm known as VTASC, which was well regarded at the time for offering better visual quality than comparable motion JPEG-based non-linear editing systems. One of the card's primary uses was for playing back Lightwave animations created in the toaster. Video Toaster Screamer. In 1993, NewTek announced the Video Toaster Screamer, a parallel extension to the toaster built by Desk Station Technology, with 4 motherboards, each with a MIPSR 4400 CPU running at 150 MHz and 64 MB of RAM. The Screamer accelerated the rendering of animations developed using the toaster's bundled Lightwave 3D software, and was supposedly 40 times as powerful as a Toaster 4000. Only a handful of test units were produced before NewTek abandoned the project and refocused on the Flyer. This cleared the way for Desk Station Technology to release their own cut-down version, the Raptor. Later generations of the product ran on Windows PCs. In 2004, the source code for the Amiga version was publicly released. With the additions of packages such as Discrete FX's Millennium and thousands of wipes and backgrounds added over the years, you can still find the Video Toaster system in use today in professional systems. NewTek renamed the Video Toaster to Video Toaster 2, and later, VT3, for the PC version, and is now at version 5.3. Since VT4, version 4.6, SDI switching is supported through an add-on called SX-SDI. A spin-off product was released by NewTek known as the TRI-Caster, a portable live production, live projection, live streaming and NLE system. The TRI-Caster packages the VT system as a turnkey solution in a custom-designed portable PC case with video, audio and remote computer inputs and outputs on the front and back of the case. As of April 2008, 4 versions are in production: the basic TRI-Caster 2.0, TRI-Caster Pro 2.0, TRI-Caster Studio 2.0 and the new TRI-Caster Broadcast, the latter of which adds SDI and AES-EBU connectivity plus a preview output capability. The TRI-Caster Pro FX, a model that was situated in line between the original TRI-Caster Pro and TRI-Caster Studio, was introduced in early 2008, and has now been discontinued. Its feature set has been added to the new TRI-Caster Pro 2.0. TRI-Caster Studio 2.0 and TRI-Caster Broadcast use successively larger cases than the base model TRI-Caster 2.0. The units within the product line above the base model TRI-Caster 2.0 enables use of LiveSet 3D Live Virtual Set technology developed by NewTek, that replaces tens of thousands of dollars worth of conventional 3D virtual set equipment alone, and is also found in NewTek's venerable VT5. Integrated Production Suite, the modern-day successor to the original Video Toaster. In late 2009, NewTek released its high-definition version of the TRI-Caster called the TRI-Caster XD300, a 3-input HD system. It was able to accept a variety of formats which can be mixed, 2 downstream keys. The XD300 also features 5 ME-style virtual inputs, permitting up to 3 video sources in one source, accessible like any other input on the switcher. At NAB Show 2010, NewTek announced its TCXD850, a rack-mountable 8-input switcher with 22 channels. It was released July 15, 2010. By 2009, the Video Toaster started to receive less attention from NewTek in the run-up to the transition to HD systems. In December 2010, the discontinuation of VT5 was announced, marking the end of the Video Toaster as a standalone product. TRI-Caster systems based on the VT platform were still made up until August 2012, when the TRI-Caster Studio was replaced by the TRI-Caster 40. This officially marked the end of the Video Toaster. Subprograms: Toaster CG is the character generation program inside Video Toaster. Toaster Edit is a video editing subprogram inside a Video Toaster. Toaster Paint is a digital painting subprogram inside a Video Toaster. See also, Quantal Paintbox, earlier system, Lightwave 3D, another high-end graphical system offered by NewTek. References. External links: Video Toaster at DMOZ, an episode of Computer Chronicles featuring the Video Toaster on the Amiga 2000, Amiga Video Toaster Flyer complete source code.